Okay, so this problem B continues on A. How many moles of MgO can each reactant in part A make? So I start out with the moles of each one, 0.0411 moles of magnesium and 0.0313 moles of O2. And they're asking me for the moles of products. In that particular case is MgO. Okay, cool. So I have the moles that I start, the moles that I want. The moles that I start are going to cancel on the bottom, and the moles that I want are going to be on the top. And remember from the reaction that it's a 2 mole to 2 mole ratio of Mg and MgO. So if you forgot, it's 2 Mg plus 1O2 gives you 2 MgO. So for every 2 moles of Mg, you get 2 moles of MgO. So 2 divided by 2 is 1 times 0.0411 moles of magnesium gives you 0.0411 moles of magnesium. Now let's take a look at oxygen. This is how much O2 we have. It's a ratio of 1 mole gives us 2 moles of MgO. So 2 divided by 1 is 2 times 0.0313 equals 0.0626 moles of MgO. And notice that one of these produces less product. That is going to be our limiting reactant. So remember, the definition of a limiting reactant is the reactant that produces the least amount of product. And you could compare moles here and see, ooh, this is less, so this is the one that runs out first, and we're going to have extra O2, okay? So magnesium because less product. And then how many moles of MgO can you make? Well, the maximum we can make is there. And how much does that weigh? Well, you start out with the moles of the product, and you go, okay, 0.0411 moles of MgO, and you multiply it by the molar mass. Remember, it's 1 Mg and 1 O, so it's 16 plus 24, which is around 40. And it's 40 divided by 1 times 0.0411 moles. Notice how the moles cancel, and you have grams, this is what you want, 1.66 grams of MgO. So putting it all together into your graph, we had 0.0411 moles of Mg, so there it is that we started with, and 0.0313 moles of O2. And you might think, ooh, this is the limiting reactant because there's less of it. But remember, the limiting reactant is the reactant that creates the least amount of product. And we determined that it was Mg. So the product, the maximum amount of MgO that we can make is based off of our limiting reactant. And we determined that that was going to be 0.0411 moles of MgO. The total mass is what the mass of MgO that we have created, and we figured out that many moles of MgO is 1.666 grams. So this is what we can create. Notice that we start out with 2 grams total, and we end up with 1.66 grams of MgO. So we're going to have extra one of these reactants, and we know that O2 is excess, so we're going to have about 0.44 grams of O2 left over in the end. So I didn't have you write that down, but that's an FYI. Some of you had numbers, you had 1 and 1, and you ended up with like 2.5. Remember, unless you're in a nuclear reaction or at the heart of a star or in a supernova, you can't really create matter. So I didn't think that's what happened in the lab. So make sure that your numbers are at or less than the total mass. Also, not all of it's going to add. You're not going to have 2 grams of MgO. It's not like remember, it's not like just adding things together and they stick. They stick in very specific ratios depending on their moles. Hope this helps.